Hi, everyone. Welcome to Hands-On Containerizing Python and Deploying to IoT and Edge Devices for PyCon Iran 2022. I'm David Tischler. I'm a developer advocate at Balena, and I'm going to walk you through all this. Let's get started. All right. As mentioned, I'm David. Welcome. And there's our contact information. Feel free to reach out if you have any questions. I'm going to move pretty rapidly, so if you are following along and find yourself getting stuck, just reach out. Let's go over the agenda real quickly. We'll talk about some introduction and background. We're going to build a very simple Python application on a Raspberry Pi. Talk about what is a container, setting up a Balena device, creating a container, loading it onto the device, make some changes, redeploy, upgrade our hardware, deploy again, and push a container halfway around the world. Now, we might not make it to that last bullet point because it is currently 11 p.m. on the other side of the world. So I'm not too sure my colleague is going to be able to join us for that one. We'll see what happens. Either way, we'll have some fun and we'll push some Python into containers on devices. But first, who is Balena? I get asked this quite a bit, and most people say, I have no idea. Well, if you've ever used Etcher to flash an SD card or a USB stick, you've actually stumbled upon us before. Etcher is an open source application. It's used literally millions of times per month. And like I said, it's used for flashing Raspbian to an SD card or perhaps Linux to a USB stick if you've ever flashed Ubuntu or maybe Fedora or some other distribution. And as I said, it's open source. It's wonderful, but it does not pay the bills or keep us in business. What actually does is balenaCloud. balenaCloud is what I'm going to use today when containerizing my Python. And it's a platform built for develop, deploy, and manage fleets of connected devices at scale. So what that ultimately means is when you have one Raspberry Pi or BeagleBone or Jetson Nano or similar type of embedded device, and it's on your desk, and you can interact with it, interface with it, that's wonderful. But when you have fleets of 1,000 or 10,000 or 100,000 devices that are scattered across the globe, well, you need a way to manage and interface and interact with those devices. And so that's where balenaCloud comes in. It's web-based control of IoT devices. It's broken down into applications, devices, workloads. You have terminal access to the devices. And I'll touch on these next 2 points in a little bit here, but Balena OS and Balena Engine are the bits and pieces that are the Linux operating system underneath, and Balena Engine is the container runtime. We'll get to those in a minute. But let's define fleet management, sort of like I covered a moment ago. If you have a device and it's on your desk, you can hook up a keyboard, a mouse, a monitor, and interact with the device. And that's great. But once you begin to scale and you have lots of devices, all right, in this case, 9. I don't necessarily want 9 monitors, 9 keyboards, 9 mice on my desk in order to control and interact with the devices. And I certainly don't want 50, 60, 100 devices on my desk. And in this particular case, you can actually see that the devices are not even all the same. Once your fleet size begins to grow and you have more and more devices out into the world, they might not all be the same. And we're going to talk about this in a bit. Your hardware may not always be identical as your IoT project grows and evolves. And certainly, once those devices are scattered across the globe, as most IoT deployments are, it is no longer feasible. Once they're no longer on your desk, it's no longer feasible to simply get on an airplane to go and update a device. So that's where balenaCloud comes in. And we'll get through that, or we'll talk about that in a moment. But first, let me circle back around to the architecture. So I mentioned Balena OS in the beginning. We're going to use Raspberry Pis today. I've got several of them ready to go. But we're not actually going to use Raspbian, or the foundation recently renamed it to Raspberry Pi OS. In the Balena ecosystem, we build our own slimmed down operating system based upon Yocto Linux. It's optimized for embedded devices and IoT use. It is minimal by design. That is on purpose. When you're deploying devices out into the field, you want an absolutely lightweight, minimal OS, nothing more. It does have redundant root FS partitions, which is a nice feature, so that as devices are out in the field, if you accidentally push an update that doesn't go quite according to plans, you can always roll back to the previous known good configuration. That operating system is intended to do one thing and one thing only, and that is run containers. All of the workloads are envisioned and should be in containers. That operating system runs Balena Engine. Balena Engine is a purpose-built container engine, again, targeting IoT devices. Same concept applies here. Minimal by design, lower RAM and resource requirements, and delta pools is an important feature, especially for devices that are connected over cellular, where if you have, a device that has a rather slow, perhaps a 3G, maybe even a 2G connection, you don't want to download the entire container every time that you push an update. You really only want to download the difference between the old container and the new container. And so that's an important feature for devices that have limited bandwidth. Both Balena OS and Balena Engine are open source. They're on GitHub. You can use them. You can fork them. You can use them totally independently from balenaCloud. But we'll go through the balenaCloud process here. In this slide, I only want to make one or two quick points, but essentially, as a developer, what you are doing is writing all of your code locally on your desktop or laptop. You're going to craft your Docker files. I'll show you that. We'll walk through that. And you're going to push those up to the cloud builder. The balenaCloud builder will churn through those recipes, build the containers, and push them to the devices. The devices maintain a VPN connection, so you always have, back to balenaCloud, so you always have connectivity from balenaCloud to the device, so long as the device has Wi-Fi, Ethernet, cellular, or some sort of connectivity. So let's begin. Now, this is PyCon. I am an IoT and fleet management subject matter expert. I am not actually a Python subject matter expert. So I started to think about this. How am I going to come to PyCon and teach a workshop on Python for IoT? What could I possibly develop that would teach my audience something new and innovative with Python and IoT perspective? And I quickly came to the realization that I am an IoT expert, not a Python expert. I'm a scaling expert. So rather than try to come up with some new innovation, how about we actually take a very simple application example, and let's start off with a BME 280, which is a very cheap, very simple temperature sensor. Quite honestly, it's not the highest quality one out there, but they're a few dollars and they're readily available, and they work great with a Raspberry Pi. There are loads of different implementations of the BME 280 on various devices, and I'll actually show off a couple of different ones in just a bit. But I thought, okay, how am I going to wire up my BME 280 to the Pi. And what am I going to run? Am I going to write some Python that allows me to grab the temperature and the humidity and the barometric pressure from the sensor and render it, in a terminal or on a dashboard? And I thought, well, I could do that, but that wheel has already been invented. There is no need to reinvent that wheel. And sure enough, in the pip library in pypi.org, there's already a pre-written rpi.bme280 library that does exactly that. So let's just use it. Let's just start with Raspbian and install that Python library, that rpi.bme280. And they also give you there a quick snippet of code that will display the values. So I do a copy paste and I drop it into my terminal. And sure enough, it seems to work quite well. I can see the device is detected on I2C, run the Python, and I've got my values. So that's excellent. Now for my IoT project, though, I need to build 500 of them. That is not quite as simple. I could flash Raspbian. I could connect my keyboard, my monitor, my mouse, do my installation of the pip package, copy and paste the code snippet, and run it 499 more times. And it will take me forever. So there's got to be a better way when scaling. In this particular case, I'm going to use Balena. There are certainly other methodologies, products, services out there to achieve this. Any of them will work. I'm simply saying do not copy and paste and do that 499 times. There are better ways. So I'll use Balena in this particular example. And it's pretty simple. I'm going to walk you through the process with Balena. I'm going to do it via the slide deck first, and then we'll hop out and we'll do a live one, which I've got on my desk ready to go. But first, let's stick to the slides. If you already have a Balena account, wonderful. If not, go to balena.io and you can sign up. You can see there actually that the first 10 devices are free and full featured. I do not ask for a credit card. I do not ask for any other information than creation of a name and a password for your first 10 devices. It is not until device number 11 that we will very politely guide you toward one of the paid plans. But like I said, those first 10, they're free, they're fully enabled, and you can play around with the platform. So register for an account, you get signed in. As I said, just email address and a password. When you get signed in, you come to the dashboard. Your dashboard at the moment has nothing in it, though. So you click the blue button for Create a Fleet. A fleet is the bucket that all of your devices will then go into and will all run the exact same workload. You can create multiple fleets when you go to segment out, whether it is geographically or type of device or different workloads. And so you can sort of begin to orchestrate how you distribute your workload to lots of devices. But the fleet is the bucket that the devices will sit in, and all those devices run the exact same workload. So multiple fleets to do different things. When you click on the Add Fleet button, you give it a name. I've created one here called PyCon iRan, and I've chosen a device type of a Raspberry Pi 3. And the next thing we need to do now that we have the bucket created is add some devices. Well, that's pretty simple. There's a blue button for add a device. And what we do is we come up with a pop-up menu here that says, what is the device type that you are attempting to add? You can choose between development versus production. Production disables remote SSH access, turns off serial console, and a few other hardening techniques. For purposes of it's still on my desk, I'll choose development in this particular case. And then you can choose from Ethernet only or Wi-Fi plus Ethernet. The blue button at the bottom says flash, and that'll flash. You know what to do in that particular case, as we talked about Etcher. For a Raspberry Pi, it uses an SD card. BeagleBone comes in different formats of onboard storage or SD card. Jetsons come in various formats. You can get them with eMMC or SD card slots. x86 type devices will normally have an SSD like an Intel NUC. So it sort of depends a little bit on what your target hardware is that you're deploying to as to how you go about. But we're talking Pis today. So we're going to flash the SD card. We'll do that with Etcher. If you don't already have Etcher installed, go and grab it from the Balena website. You can hit the green button there to download. Launch Etcher. Go through the process of select the image that we just downloaded a moment ago. That OS was custom built for that fleet. It's Balena OS, like I talked about earlier. And select the target once you have your SD card inserted and hit the flash button. Put the SD card into the Pi, turn it on, and in about a minute or two, it will boot up, check in online, register itself with balenaCloud, and appear in your dashboard. That's wonderful. You now have a device connected to balenaCloud. The device is on your desk. balenaCloud, of course, is an abstract web service. They are connected by VPN, and you have the ability to now interact with the device on your desk. You can click on its name. You can get a couple of values, CPU, temperature, storage, memory. You can see its IP address, and you have the ability here to view logs coming off of the device and open up a terminal to the device. So at this point, I have no monitor, I have no keyboard, I have no mouse, just have the device connected to the cloud. So that's great, but where's our Python? The device is not doing anything yet. There is no container on it yet. So we need to put it onto the device. I've got a development machine here, simple Ubuntu installation, and I need to create a Docker file consisting of that same snippet of code that we used earlier in Raspbian. And we'll come back around, like I said, we will do all this live, but just for purposes of demonstration here, I'm going to copy paste that snippet from the PyPy website, and I'm going to create a very simple Docker file. We have some documentation on the Balena website in the docs section about how to go about creating Docker files, creating your containers. Of course, you can always Google that. That Docker has fantastic documentation of their own as well. And I'm going to also copy in so I've got the 280.py with the snippet, and I've got my Docker file ready to go here. And the next thing I'm going to do is I need to push that up to the cloud to be built, up to balenaCloud, to get parsed and distributed onto that Raspberry Pi. There's some tooling that we build called the CLI. Install the Balena CLI, and then you have the ability to SSH, push containers, grab device and application information. And in this particular case, then, we're going to run a build. So here's the CLI installed, and you now have the Balena command available. And I'm going to run a balena push fleet name that we defined earlier. And that is what will then, you can see in the screenshot here, take the contents of your Docker file, send them up to the cloud. Cloud Builder churns through that recipe and distributes it to all of the devices in that fleet. At the moment, I've only got the one device in that fleet, but that's enough to get us started. We can always add more devices, and they're just going to do the exact same thing that the first device was doing. When the push is complete, you'll see a unicorn, so that's how you know you've been successful. Always look for the unicorn at the end. You can see here that the release was successfully created and the container has been built. It's going to now be orchestrated and sent down to the device. The device will download the container. At the end of the process, it'll begin running the container. And you can see it ran my little Python snippet that we copied and pasted in. However, in the logs, I can see that it's actually doing exactly what I told it to do, which is run that little Python snippet. However, that Python snippet is a discrete one-time run. It runs the container, and then the process finishes and the container stops. The Balena engine on the device will say, that's strange. The container stopped. All right, let's start it back up. And it will continue to loop in that manner because my Python simply exits out and humidity and barometric pressure. Well, it's great because that's what we told it to do. So that part is working. But I think we actually could do a little bit better. And instead of just run the Python as we told it to do, let's instead alter the Docker file and put a while, do a loop here. Save the Docker file and re-push. So what we're doing is pushing a hotfix to the device. That's ideal in the scenario of IoT because the device is still on my desk. That is wonderful, but it's not going to be on my desk forever. It's going to be out in the field and not quite as easy to access. So point here is you can update the container, update the Docker file, and just rebuild the container and redistribute the container, and it'll go out to the devices. Again, one at the moment, but about to be more. The new container will build, go through the exact same steps as before, and end up on the device. And when it does, now I can see in the logs that the loop is just continually running in the container, and the container stays alive. So that's pretty neat. We updated over the air from our first container, which it did work, but it wasn't ideal, to this new one. But let's make some upgrades. So we've seen how you can update the container, but what happens if we actually swap hardware and we upgrade a device in the field? As IoT projects evolve, especially in today's environment with chip shortage and supply chain issues, if you can't get the exact same hardware that you got at the beginning of your IoT project, you may have to make some sacrifices or some upgrades, some improvements, depends on what is available. And your fleet might become more heterogeneous and have sort of a mix and match of hardware. Now, you need to be a little bit cognizant of, like I said earlier, you may have to then distribute into multiple fleets. But in this particular case, I'm making a pretty simple switch. And I'm going to swap out my BME 280 for a BME 680. And the 680 is more accurate, and I believe it also adds air quality to the equation. So pull my 280 out, put my 680 in. Well, if I want to maybe take advantage of that 680, now I could leave it as is, and it could continue to run the container that we've pushed, the second one, the improved one. Or we know that the over-the-air update is working. I'd say let's add even more functionality. Let's get some better Python. So at Balena, we have a team that builds projects. There's a whole bunch of them. There is a signage and kiosk project that uses Screenly, which is an open source application. Actually, I think it is a Python application, to be honest. We've got some audio projects, turn your old speakers into hi-fi for over-the-air streaming to a Pi. We do a lot in LoRaWAN, so there's both Helium and the Things Network projects. But for right now, we're talking weather, we're talking simple IoT, we're talking Python. We have a project called Balena Sense. Build an air quality monitor with Influx, Grafana, and Docker on a Raspberry Pi. Well, that's perfect. That's exactly what we want in this case. It's open source. You can go and clone it right there from that GitHub URL. I'll make sure that the slides are available as well. But in that case, what we're going to want to do is run a git clone on that project. We can see that it's got a lot more files than the 2 simple files that I had previously written. It's also using a Docker Compose as opposed to a Docker file, well, in combination with a Docker file. And again, there's lots of documentation on this out there, but suffice to say that we're using already made stuff here. You don't need to alter anything. You can just do the git clone. And you know what comes next? Balena push my fleet name, and it will do what it did, what we did the first 2 times, which is package up your local file structure, send it up to balenaCloud to be built, churn through them, and then send them to the devices. At the end, we get the unicorn. And in this particular case, we built 1, 2, 3, 4, 5 discrete containers. Influx, the dashboard, some MQTTs, a connector block, and a sensor block to be able to read the values. Again, this was all pre-written. It's all in GitHub. You can investigate those. You can, it's open source. You can use them in your projects. The device will download the containers, and we come away with a much more robust implementation, because now we've got Grafana doing some historical time series on the temperature, pressure, humidity, and it's not on screen here, but air quality is included as well. So we've taken the same steps, the same process, and built containers, pushed them onto devices, and all of the devices that are in the fleet will run the same workload. So from a scaling perspective, it doesn't matter where those devices are. In this example, I actually, although I was showing you the one on my desk, I'm in Arizona, Phoenix in the United States. I've also got one deployed in Barcelona and in Noida, Delhi, in India. So my fleet is global, but as I mentioned, it's now approaching midnight in India. So I don't think we're going to be deploying to that one right now, halfway around the world. But the point being, the devices have already been shipped out. They are on 3 continents, and I can still push containers to them. So we'll think about this. We built the container, we loaded it onto the device. Containers can be updated, they can be changed, they can be added, improved. We can push them over the air no matter where the device is located. The container is what has your workload or your application in it. We deployed the 3 devices on that previous slide, but could have been 1,000, it could have been 10,000, it could have been 100,000. The largest fleet in Balena right now is just under 70,000 devices, and that's a helium gateway manufacturer. All in, there's probably a couple 100,000 devices connected to balenaCloud. You can manage and you can interact with them from the dashboard. So you can prototype on a Raspberry Pi, but you can go to production with enterprise-grade hardware. The container is going to run the same. The devices will show up in the dashboard, and you can push your containers to the entire fleet in one fell swoop. So scaling is easy. So that's how you scale a Python application in an IoT or Edge AI or Edge computing scenario. So a couple other things to try here. I'm going to drop out from the slide deck in just a moment, and we'll get going on a real live build. But I just want to make one quick note that as I was talking about, we build a lot of projects at Balena. So if a BME 280 or a weather project is not quite your cup of tea, there's lots more. Like I said, there's Balena Sound, there's Balena Dash, which is the kiosk project. Open Data Cam is a neat one running on a Jetson Nano that uses CUDA for object detection. I mentioned we do a lot with LoRa. There's Home Assistant, that's always neat for home automation. So those are, sample starter projects to kind of get you going. But then as you iterate, if you do intend to build a custom product, you can kind of take these as building blocks and get going, or you can just write your Docker files, write your applications. As long as they are in containers, you can push them to the devices anywhere. So and that's what a lot of the Balena customers do, is they have their custom application that's what their business logic is. They containerize it, they push it out to their fleet. But these are great for getting started here. So let's drop out at this point, and I will show a deployment hands-on. Let's stop that screen share. Change the camera. There's my desk, although it's a little bright, but you can kind of see it there. So I've got 1, 2, 3, 4, 5 Raspberry Pis ready to go. I don't think we'll flash all 5 of them. It's fine. I guess we can't because I've only got 3 SD cards. I've got some sensors here as well. Let's see. On the first Pi, I have the BME 280 already attached. BME 280s come in a lot of different form factors. This is a Grove, kind of tough to see. Here's that BME 680 I was referring to earlier in the slide deck. Ooh, doesn't want to focus, that's okay. SparkFun builds some nice hardware. These are quick connects, so you don't even have to do any soldering. You can just attach right to it using a little shim that they build. This BME 680 is nice. This is from Pimoroni, and this slots right into this hat here, and then you can just attach the hat right onto the Pi. So this is a nice, easy way to add that capability without even having to do any soldering. You can just put it right in there. Let's bring up another screen share though, and we'll get the dashboard opened. Oops, turn that off and share a screen. I'll come back to the other camera in just a moment. Well, actually, I might just leave it like this. All right, so I've got the dashboard, and as I suspected, Barcelona and New Delhi are asleep. They turned their Pis off before they went to bed. It's okay, though. In the balenaCloud dashboard, like I showed in the slides, all we're going to do is click Add a Device. I'm going to leave it on a Pi 3. I'll put it on Development. You can add your Wi-Fi credentials, and you can hit the flash button. The flash button will launch Etcher. I actually have already downloaded Balena OS to save us a couple of minutes of configuration. So let's do this. Stop that one. And share. Etcher. Here's Etcher. Grab my SD card. It's ready to go. I'm popping it into my laptop. As I mentioned, I already downloaded the file earlier. I'm going to choose it in my pop-up here. Okay. Got my SD card already in the laptop. I'll hit flash. Got a pop-up asking if I'm sure that I want to proceed. I am, in fact, sure that I'd like to proceed. I think we'll use this one to start with, since we've already got the code. Well, no, we better go with this one since it's got the 280. Flash is complete. I can take the SD card out of the laptop, put it into the Pi. SD card is in, and let's power this up. I'm going to steal this power cable here. Plug in. And come over here. Okay, so now powered up the Pi. It's going to check in with balenaCloud, as I showed earlier. Let's bring that one back. We can close that out. And once this one boots up, we are going to see it appear in the dashboard. Give it just a moment. Pi 3 is not the fastest device. I probably should have chosen a Pi 4 to save us a bit of time here, but that's okay. While we are waiting for it to boot up, check in online, and appear in our fleet, let me also get my Ubuntu VM up and going. And now that this is here, I'll bring the camera back to me as well. There we go. Now, Ubuntu is on my other monitor. So looks like we got our new device coming online now. Dull hour. All right. So you can see. Pop up. So we can see the device has come online. And it's going to start downloading the container that I've already pushed to it, which in this particular case is going to be the very first one, the 280.python snippet. And I have a strange feeling that it's the very first implementation, which is going to do the container restart loop. But we can fix that. We know how. So it's going to download its container. In the meantime, I do have, well, my Wi-Fi is not the fastest. This might take a moment. Well, it's making some good progress. All right, we'll give it another minute. I've got the VM ready. So let's give this one more moment to finish. And if you're following along at this point, you can race my Pi. If yours is going quicker, congratulations. We're getting there. Like I said, I probably should have chosen a Pi 4 instead, but that's all right. The 4s are significantly faster. The other thing that can affect your speed here, besides just raw Wi-Fi performance or Pi 3 versus Pi 4, is the SD card. If you can get yourself a high quality, fast SD card, you can also significantly improve your performance. The other thing about a cheap SD card is they tend to wear out quickly. In IoT deployments, you're much better off just spending a few extra dollars and getting a high quality card that will last longer. All right, looks like the container has finished downloading. It'll take just another moment and it should start running. And we should see in the logs the information come off the BME 280. But I'm gonna make the switch at this point now that we know that the device is online and the container's going. Uh-oh. Looks like my I2C is not being detected well. It cannot find my sensor on the I2C bus. Well, then that means that I did not attach it properly, but that's okay. I'm not too worried about that. What I'm going to do instead is come over to that VM. Let's stop this share here. Bring in VM. And we can see that I've got Ubuntu here. And sure enough, yep, I had the python.280.py running. We can do exactly what we did in the slide deck. Get rid of this line. Change it to the while loop. and then do our push. So we'll save it. Balena push on Iran. And it will go through the process of building the container, like we talked about, uploading the package, and in the meantime, I did a better job attaching the sensor. Actually, let's do this. So that container's building. We'll switch back. Take another look at Pi. Since I did a poor job of connecting these pins to the 280, I'm holding them in place. I should have soldered them. That would have solved this problem. But now that I have them held in place properly, I can share the dashboard again, and we can see we are getting the data being read, the container exiting, and the data being read again, and the container exiting. So it's doing exactly what I thought it would. And over in Ubuntu, looks like the build finished. We'll get our unicorn in a second here. There he is. And looks like our delta size is pretty minimal. We talked about that earlier, which is only the change will be sent to the container. We'll come back to the dashboard. And now we can see we actually missed it updating. It was that fast, but the new container has already downloaded. That delta size was only a couple of kilobytes. It downloaded it that quickly. We missed it. And you can see, though, in the logs that it killed the previous service, deleted the image, installed the new service, and started the new service. That's means the container. And our readings are now coming through in a loop. So it worked. So that's it. Now, let's come back. I'm going to switch my camera back to me because I don't want to hold this sensor in place too much longer. And turn that off, and we will wrap it up here. Let's get the slide deck back for one last moment. And where did the slide deck go? Here it is. There we go, we're back. All right, so here's where we left it, with some projects to try. Next are some resources. We have lots and lots of projects on the blog. Over on our forums, we build projects, like I mentioned, Community members are building projects. There's lots of fun stuff in there. And of course, GitHub. I have in this link the Balena Labs GitHub repo because they are the ones that produce a lot of the content that, like I said, those sample projects and things. But there's also a GitHub repo for, like I said earlier, Balena OS or Balena Engine and some of the other open source bits and pieces as well. Q&A time. So we went through a lot of material here. I'm happy to answer any questions. As I mentioned, you can simply reach out to us. You can tweet to us. You're welcome to email me. You can post your questions on the forums like I just showed the URL to a moment ago. I'll try to, I'm recording this on Monday, and I'm going to have to do some math to figure out my time zone trivia. I'll try to be available live for Q&A as well. I'll have to just simply double check. I think it's about a 13-hour time zone difference, if I remember correctly. But I'll see if I can poke my head in for when this airs live, for when it's played back, and see if I can do some live Q&A as well. But otherwise, just reach out. Happy to answer any questions. So hopefully you learned a little bit about IoT fleet management. As I mentioned, I'm not a Python expert, so I couldn't teach you any new Python tips and tricks, but hopefully I gave you some perspective on how to scale your Python. I used a pretty simple weather, temperature application. I'm guessing that your applications are probably much more complex, but the theory is the same. Containerize it, push it to as many devices as you would like to. All right, that's it for me. As mentioned, if you have any questions, just let me know. Bye, everyone.